Scalable exploration of complex objects and environments beyond plain visual replication. Acquisition, reconstruction, and exploration of paintings from a retable of San Bernardino. In this video, we demonstrate the application of the advanced capture, reconstruction, and display techniques developed within EVOCATION on two of the selected paintings from the retable of San Bernardino use case at the Pinacoteca Nazionale, which is part of the National Archaeological Museum of Cagliari. The retable of San Bernardino comes from the chapel of the same name, located in the counter facade of the Church of San Francesco di Stampace. The church was demolished in 1875 and the 25 panels of the retable were placed in the collection of the National Pinacoteca of Cagliari. The central panel from retable depicts Christ in piety supported by an angel, painted by Joan Figuera in Catalan Flemish vase. Although the state of conservation does not allow viewers to fully appreciate the lower part of the composition, the rest of the panel is well preserved. The second is the painted panel of the Hebrew prophet Daniel inside a polylobed oval. The text on the cartouche, held by the prophet in his hands, quotes, "Tempta nos obsecros servos tuos," translated as, "Please test us, your servants," from the book of the prophet. The selected paintings are placed at position 1 and P within the retable of San Bernardino. For Milik capture, multiple photographs were taken from a fixed camera and different light positions by uniformly moving a light source in a hemispherical virtual path in front of the object, as shown next. We acquired 276 images, light directions with a sub-millimeter resolution. You can see the handheld LED-based white illumination, the 36 megapixel Nikon D810 camera, the region to place paintings and calibration targets for the acquisition. Here's the acquisition setup after placing the painting along with glossy spheres and white targets for light and color calibration. The Milik was processed to extract BRDF and normal map using the calibration technique recently introduced by CRS4 and the processing methods developed within the project. For further details, please refer to the cited bibliographic sources publicly available on EVOCATION website. These are the per pixel normal and ward BRDF component maps extracted from the Milik data for painting Christ in Piety. Here are the same maps extracted from the Milik data for the painting of Prophet Daniel. Starting from the reconstructed data, the paintings are inspected using novel exploration techniques for relightable multi-layered models developed within the project. For more details on the techniques, please refer to the cited bibliographic sources publicly available on EVOCATION website. In the following, we show example inspection sessions on both a desktop platform and a large-scale multi-touch display installation. Multi-scale inspection together with relighting allows users to appreciate the surface characteristics of the model, which are generally hardly visible to the naked eye. Multi-layer exploration is supported through interactive lenses. Our novel controller supports focus and context exploration by translating user actions to the joint adjustments in camera and lens parameters that ensure a good placement and sizing of the lens within the view. This journal approach overcomes the limitations of current solutions, which force the users to continuously switch from lens positioning and scaling to view panning and zooming. We now show a live demonstration of our system on a 98-inch multi-touch display. By using a lens-based approach, the user can concentrate on its focus area, while the context area fills the peripheral vision. We now illustrate the behavior of the system on the second painting. Multi-scale exploration with relighting enhances surface details for in-depth inspection of the model, which is otherwise not possible with the naked eye. The lens could also be used in exploration while adjusting the relighting to exaggerate the surface details and features from various angles. To conclude, we show an excerpt of an exploration session on a 98-inch multi-touch display. Such a setup is particularly useful for museum settings, since multiple viewers behind the viewer can appreciate the exploration session. This video has shown the practical application of research in the area of cultural heritage computing. We encourage you to refer to original publications for further details. We warmly thank the National Archaeological Museum of Cagliari, and in particular its National Gallery, for access to the artworks for the purpose of digitization and for collaborating on our research work. The work presented here was supported by the European Union under grant EVOCATION and by Sardinian regional authorities on projects supporting CRS4 visual computing activities.